It's not the calories from sugar that make you fat. It's the activation of this pathway. I think we're going to cure obesity and diabetes really in the next few decades.
I love the title of the latest book, Nature Wants Us to Be Fat. Love the content as well. But a good jumping off place to open up this conversation, why would nature want such a thing?
Absolutely. So it turns out that many animals in nature actually desire to have enough fat to survive when there's no food around. So that's true for all animals. So all animals will carry a certain amount of fat, but there are some animals that will really put on a lot of fat when there's periods of food shortage. And everyone knows about hibernating animals and how animals will get really, really fat before they hibernate. And then when they hibernate, they use the fat as a source of energy to help them survive. So it turns out that in nature, the putting on of fat is a very designed process. And it's, animals activate switches to put on fat. And it was because of that led our research into trying to figure out what that switch was and to see if it was relevant to us. And historically, we wanted to be able to have enough fat to survive food shortage. But now there is not so much food shortage. So all we're doing is putting on the fat because we've learned how to activate this switch. We didn't actually, our biology has taught us how to activate this switch.
So what I'm hearing you say, basically, genetically, our physiology has allowed us to survive and get to this point because we naturally want to put on fat. But now that we're in this modern world, 21st century, with a lot of abundance, at least for select areas of the population, that's not across the board. But now it's gone the other way, and the genetics and the physiology, we have to work against them. Otherwise, we're just going to put on all kinds of weight.
Yeah, and the big thing was not that, we've just learned how to put on fat with any foods. The switch is actually activated by specific foods. And so there is a biology that activates the switch, but it's triggered by specific foods and not others. And so what's really cool is that understanding this biology allows us to actually figure out, what we should eat and what we shouldn't, and so forth. And so so since we understand the biology of how it works, it really gives great insights into nutrition and disease.
Well, let's jump right into it. The $1 million question, What foods are making us fat?
Well, that is the big question. But let me just begin, actually, if it's okay, begin by saying what this switch is. So the switch is not just putting on fat. The switch is actually preparing for times when there's no food. And putting on fat is one of the aspects of it. So basically, normally, animals try to regulate so that they have, a little bit of fat, but 5-10% body fat, but they have that just for emergencies. And basically animals will if they eat more in one day, they'll eat less the next. If they they'll really try to keep their weight normal. And there were these studies a long time ago where people would take animals and they would fast them. And so that they would be forced to lose weight, and then they would let them eat, and they would go right back to the weight where they wanted to be. Or you could take animals and you could force feed them, and make them gain weight, and then you could stop the force feeding, and they would go right back to their normal weight. So this was, because normally animals regulate their weight very well.
And another layer I've heard you talk about in that respect, just to add to that, is the fact that they'll actually do that to whatever season they're in. So if it's been a period of time and they're now in the fall season when a lot of animals are preparing to hibernate, they're going to go to that new level of weight gain versus the baseline.
Yes, that's exactly right. So like if you, like an animal will tend to gain weight in the late fall, before winter comes, they tend to gain weight a little bit, even the ones that don't hibernate. But the ones that hibernate they actually have to gain a lot of weight because they're not going to eat for months. They're going to be hibernating. They're going to be living off that fat. But you're right. If you fast an animal in like March, and then in come June you let it eat, it will eat back to the weight it wants to be in July. When it gets to July, it actually tracks to the weight it wants to be at that time of the season. So I mean, animals really know what they're doing. But what's really interesting is that some animals will like double their weight in a very short period of time to prepare for periods when there's no food available. And in my book, I talk about the emperor penguin because this guy really, I mean, they can double their weight in fat. I mean, it's just amazing how big they get. And likewise, a lot of animals will gain a lot of fat. You can be a bird preparing to migrate a long distance, or you can be you can even be a primate like a lemur, and some lemurs will hibernate during the summer. And during the dry season, when there's not a lot of water or food around, especially water, and they will hibernate and store fat before they hibernate. They call it estivation, but it's the same thing. And then they survive off their fat while they're in their hollow of the tree. So there are all these, there are these things that kind of trigger a switch. And when you look at this switch, it isn't just the fact that the first thing is it's actually a behavior and a biology. So the behavior is that they start becoming hungrier, and they're not satisfied when they finish eating, a regular meal. They're still hungry, and they get thirsty, and they actually search for water, and so it's both hunger and thirst. And then they actually activate a process where they forage. They start foraging. So that means that they're looking for food, and they will wander significant distances. They'll go into areas they're not used to being. They will, they have to change their behavior and, become a little braver. And they can't spend a lot of time focused on one area, so they're kind of looking all around. And so foraging is really a specific behavior. And associated with that, they try to conserve their energy. And so the way they do that is while they're foraging, they don't conserve their energy. They let their burning energy, because they're foraging. It's like a type of exercise. They're out there searching for food. But when they're not foraging, they drop their metabolism lower than normal. So we call that resting energy metabolism. So they, basically, I tend to fidget. I don't know. I'll probably be fidgeting during this talk, because I fidget all my life. I fidget, but an animal that drops its resting energy metabolism, they don't move as much. So they actually, when they're not doing anything, they kind of sit there. They drop their metabolism and they move less, even, and they conserve their energy. So the net energy spent at the end of a day can be about the same as a normal animal, because while they're foraging, they're spending energy, but then they conserve it when they're not. And that makes sense, right? The animal wants to try to store as much fat, but it's got to get the food too. So, and then they start becoming insulin resistant. And insulin resistance is, where you try to move the calories to the brain instead of to the body. So normally, insulin is a hormone that moves glucose into cells, and then when the glucose gets inside the cell, then it's metabolized, and it's like an energy source. It's the main energy we get from carbs is glucose. So insulin moves the glucose into the cell from the blood, but most, like the muscle, needs a lot of insulin to move the glucose in. But the brain, there's a lot of the brain that doesn't require so much insulin. It requires a little, but not so much. And so if you become resistant to insulin, then the glucose in the blood can't get into the muscle as well. So it goes to the brain, and that's what you want when you're foraging. Even though you want to have the muscles have enough energy, what you really want is you want to be able to keep your mind, with sufficient fuel that you can make wise decisions as quickly as you can. So insulin resistance is part of a survival response. If you starve animals they will drop their insulin levels, but they'll also become resistant to insulin, So it preferentially keeps the glucose going to the brain. So they become insulin resistant. And then you start. The biggest trick, Jesse, the biggest trick is that there is a shift when you eat calories. Calories can go to make energy, and the energy we use to do our activities, and that energy is driven by a substance called ATP. But when so calories get converted to ATP, and then we burn the ATP to do the things we want. But there's a stored energy. Stored energy is not ATP, it's fat. And fat can be turned into ATP, but it's basically a stored energy. And the big trick of the switch is it shifts the calories we're making away from making ATP towards storing it as fat. And the trick is it stuns the mitochondria. The mitochondria are the little components in the cell that make ATP. They make a lot of ATP. And there's an oxidative stress that occurs to those mitochondria. So it kind of prevents the mitochondria from making all that ATP. So the calories get shifted to fat. And at the same time, the ATP levels drop. And when the ATP levels drop, that's like an alarm signal that says, hey, I'm hungry. I need to do these things. So it actually encourages you to eat more food because it's tricking you into thinking that the body doesn't have enough energy. But what's really happening is there is a lot of energy. It's just going to fat. And then what it does is, as it makes it shift to fat, it reduces the burning of fat so that you can't really use the fat. And so the fat keeps accumulating because you're making more. You're not breaking it down. And guess what it does? It causes obesity because you keep eating. And eventually, as the ATP levels slowly come back up, this switch turns off. So the switch initially is kind of turned on and off. So like if you eat a lot of, so if you activate the switch, it can go on for a few days initially, and then, or a few hours even. But then over time, what happens is the switch is basically turned on for, pretty much all the time. If you're eating a lot of the wrong foods, it sort of turns it on all the time. And then later on, after you've been obese for many years, those mitochondria that make ATP aren't working very well because they're continually hit with that oxidative stress. And so at that point, then, the body just can't keep up with making all the energy. Some people call it aging, but basically we're producing less energy because of this oxidative stress. And at that point, even if you correct the switch, you may stay overweight and kind of in a low energy state. So there's like different phases. So there's this initial phase where we can regulate our weight well. And, when you're young, you can regulate your weight well. And even if you turn on the switch, it's only for a little while. And then you can rapidly lose it. And then pretty soon, then you have the switch on most of the time and you start accumulating the weight. You can still beat it, but you have to modify diet pretty significantly. And then there's a point where you have to do something special to recover from your overweight, because at that point the mitochondria have been injured, so you actually have to stimulate their growth. So those are the stages, and so then so that's sort of how the switch works. I don't know if you want to talk about that before we go into what activates the switch.
Well, we're going to get to that, the $1 million question. But before we do, just to summarize essentially what you were saying there, is that nature doesn't make mistakes. Even though these are things that are undesired for us as humans here in the 21st century, these aren't mistakes. Right. And they all have a reason why they're happening with the physiology.
It's so true. It was desired. And in fact, we can get into this when we should talk about, tastes and why we developed the tastes we got, because it was all related to this mechanism. Nature, we've gone through thousands of generations where we keep moving towards, responding to the climate and the nature and what's going on around us, and evolutionary type changes, as we would say. And for millions of years, what was driving us was trying to find a way to survive. The biggest issue was, what do we do if there's no food, if there's no water, if there's not enough oxygen? And so developing processes in our body that could protect us was really key. And this turned out to be a huge biologic pathway that all animals use to try to protect themselves. It looks like it's probably all animals. And so it's a very basic pathway. And the problem is now our civilization has improved so much, as you pointed out, that, getting food is not such a big issue for many of us. We just go to the grocery store and pick from one of 20,000 types of foods there. But, and so the problem is we've got this biology that hasn't corrected for that. And so now we're picking, a lot of us are making poor decisions by eating foods that we know that are bad, but we crave them or we like them, and they trigger bad things. And so we should also at some point talk about this craving pathways and why
For sure. I'm curious though, we're obviously a species that has a problem regulating this switch. Are there other animals in nature? Obviously, the world has changed so much, especially in the last, couple hundred years. Are there any other animals that struggle, or are we the only ones?
Oh no, well, there are others too. So pets, for example, obesity in pets is really becoming a problem, and also in zoos, obesity in zoos is a huge issue. I've also been involved in things that are going on in cats, not just domestic cats, but even wild cats. And a lot of this seems to be triggered by food or climate change. Actually, I was just interviewed. I do a lot of climate change research too, and I've been able to link climate change with obesity and diabetes and epidemics of kidney disease. And that may be worthwhile talking, because climate change actually is going to be a challenge for us as well.
Let's talk more about that while you've brought it up.
Well, so it turns out that there's some very, very, we're having these huge heat waves in Europe and, gosh, just about everywhere. And of course, there's the obvious things that heat waves do. One obvious thing that heat waves do is a lot of people retreat away from being outside and, going to places where they're not as active. And inactivity is linked with heat stress, because it's just, especially, you can't work outside very long. And inactivity and, heat will drive, a lot of people will drink the wrong hydration fluids like soft drinks. So one very obvious thing is that heat stress can be associated with the development of obesity from less activity and drinking the wrong hydration fluids like soft drinks. But when it comes to the switch itself can be activated by heat stress. And so I think what I'd like to do is to first talk about the classic ways the switch gets activated. And then we can talk about...
Yeah, let's not keep people waiting any longer. Let's get into it.
Yeah, let's get into it, because so it turns out that a lot of animals will eat fructose as a mechanism to help them gain weight. The classic is the bear, and when it's wanting to put on pounds in the fall, it will find berries and start eating them. And small amounts of fruit are really healthy. I'm not going to challenge that. It's really true. But if you eat tons of fruit like these animals do, you can get a huge dose of fructose. So fructose is the main sugar in fruit. It's what makes fruit taste sweet. And apples are sweet because of the fructose content. And it's the main nutrient. And if you eat a lot of fructose, it turns out that is very specific at activating this biologic switch. So what happens is, if you eat a lot of fructose, you will become hungry and you become foraging and all those kinds of things. And we were, had a big role in kind of figuring this out, but there are many other groups doing it. So the science we did was to study how fructose activates this switch to become hungry and forage and all that. And what we found is that if we put fructose, especially in drinking water, that mice and rats and other animals will rapidly lose their control of appetite. Initially, it's like a regular calorie juice. It's, the first several weeks, if you're just exposing an animal and they like it, they'll seek it out. They'll drink a lot of it because it's sweet, it tastes good. But initially, when they drink more sugar water or fructose water, they'll eat less food. So they actually try to regulate their weight, and they won't gain weight that first, several weeks. And then there's this transition that happens, and it kind of is different in each animal. But after several weeks, suddenly it will lose its control of appetite. And when that happens, it will not only drink all that fluid, but it will eat a lot of chow. And so it's actually eating more, and it will reduce its energy metabolism, and it will fully activate this biologic switch. And it will become insulin resistant, and it will increase the fats in its blood and in its liver. Actually, it develops what we call the metabolic syndrome. And this metabolic syndrome, which I was taught was a pathophysiologic problem. In other words, it was like a disease process. You become insulin resistant, so it's like a disease process because it's going to progress to diabetes. And you get elevated blood pressure, and it's going to progress to hypertension. And you're going to have low-grade inflammation, and that's going to cause problems and atherosclerosis over time. So metabolic syndrome has been called a disease because, and about a quarter of us have it in the U.S., a quarter of adults. And it's kind of the preceding thing that precedes the development of diabetes, severe obesity, diabetes, hypertension, kidney disease, fatty liver, and liver disease. And so it is a precursor. It is the natural step. When you're eating too much, some people will get what's sort of a healthy obesity where they gain fat, but none of these other features. But most people will actually develop this whole spectrum that we call the metabolic syndrome. But the metabolic syndrome is actually what these animals want. They want to be insulin resistant. They want to have slightly higher blood pressure. They want to hold on to salt better, and they want to put fat in their liver and in their blood and in their tissues because, when you're burning fat, you can burn it from all these different sites. It's like a way to store the fat. So they want it. It's just that we keep activating it. And what becomes fatty liver turns into cirrhosis and end-stage liver disease. And what begins is slightly elevated blood pressure to keep your blood pressure high during times when there's not a lot of food around and you need to have that good circulation. Then suddenly it becomes a pounding circulation and high blood pressure and strokes and heart failure, which come right off of high blood pressure and that inflammation that initially is there to help you fight infection and to fight stress. And having a little bit of inflammation is a good thing if you're under stress because it kind of heightens your immune system. It protects you when you're under stress. So if you get that viral infection, you can help fight it a little bit better. But if you have chronic inflammation, it causes injury to the blood vessels, and they don't dilate as well. And they constrict more. And what happens is you start building up this thing called cholesterol plaques. And then before you know it, you have heart disease. And inflammation is now recognized as a major risk factor for heart disease. And metabolic syndrome is a major risk factor for inflammation. And eating fructose is the thing that initiates that. So it turns out that fructose initiates this pathway that creates metabolic syndrome. The metabolic syndrome, when it's persistent, causes a whole set of diseases. And obesity is not in itself the issue. It's not obesity that we're worried about. It's about these accompaniments. Why? Why? So when we gave fructose to animals and this happened, I go, no, it can't be. So fructose is disrupting this whole thing. And one of the key things we found was that fructose caused leptin resistance. And leptin is this hormone that's released by the fat. And leptin kind of is that signal to tell us, hey, you've eaten enough. You're full. Don't worry about it. Don't eat anymore. And so leptin is really an important hormone. But people who are overweight or obese typically become resistant to the effects of leptin. So they end up having high levels of leptin in their blood, but they're still, they don't stop eating. And you can actually show it in an animal. If you inject an animal with leptin, they'll reduce their eating for the next 24 hours. So what we did is we gave fructose to these animals that kept eating. So we thought to ourselves, are they resistant to leptin? So we injected them with leptin, and they didn't stop eating at all. They kept eating, whereas the control animals, you give them a leptin and they just reduce their food intake. So fructose was causing resistance to leptin, and it was working through the brain, actually. That's where it was working. It wasn't really working in the fat tissue as much as it was working on the brain. So we then realized that fructose could do this. So then we said, well, maybe other foods can too, But let's try to figure out how it works. Why is it making you eat more? We knew it caused leptin resistance, but what was the fundamental mechanism? And this was kind of this was an adventure story. Honestly, it was like there were a lot of wow moments, and the biggest thing was kind of this recognition that fructose affects the energy in the cells. And, everyone knows that energy is really what drives us. And, energy is all these diseases like diabetes and obesity. They're all kind of like energy disorders. There's something going on with our energy. And the big insight was that, within our cells, we want to have a high energy. That is the goal. I mean, we always try to have enough ATP to be able to do everything we want. So even when we're dreaming and thinking, we're burning ATP. And so ATP is like, that's where it's at. That's where the energy is. Yeah, we got muscle, we got proteins, but it's the energy that really drives us. And so it turns out that almost all foods, we eat food to make this ATP. But this fructose, it's a trick. What it does is it initially burns the ATP fast, faster than any other food. Alcohol can burn ATP fast too. We can talk about that. But fructose burns the ATP. The ATP levels then drop. Now, normally, there's all these protection systems that animals have to keep the ATP levels from dropping. So if there's anything that causes it to drop, there's all these alarm 1, alarm 2, alarm 3, all these things that bring the ATP levels back up. But when you do it with fructose, it actually turns off these other alarms so that the ATP levels can't recover. So it drops, and there's this like blockade of the recovery of ATP. So there's an enzyme called AMP kinase that recovers ATP, and it's turned off by fructose. And the mitochondria usually just start pouring out the ATP when there's a problem, but the fructose raises a substance called uric acid, and that uric acid activates another enzyme that causes oxidative stress to the mitochondria. And oxidative stress is this term we use for a pro-oxidative mechanism where oxygen is turned into an aggressive beast that could actually injure tissues. And oxidative stress is what drives aging and wrinkles from smoke. Smoking's a big cause of oxidative stress, and it can drive aging and wrinkles and all kinds of things. But what it does when it gets to the mitochondria, it stuns them and it reduces how much ATP they make. And as I mentioned earlier, that initially that's temporary, and then the mitochondria recover. But over time, if you keep hitting it, the mitochondria can get damaged. And so what happens is fructose causes this transient ATP reduction in ATP and the shunting of the energy to fat. And so it's an energy disorder. So fructose, is used to make energy, but it's making preferentially stored energy rather than ATP. And so that is the trick.
Let me make sure I have this right before you go any further. So we have fructose at the top of the chain.
Yes.
That gets converted to uric acid. That ends up having an impact on an enzyme, which is yet to be unearthed. You can tell us what that is. And then that causes the oxidative damage to the mitochondria, shunts the energy over to producing fat, and blocks our energy production.
That's absolutely right. So there are a couple really cool things in here. So one of the first things is that the uric acid is not generated directly from fructose. So it's a specific chemical. So fructose, like all nutrients, is broken down to carbon dioxide and water. I mean, basically all food gets broken down eventually down to carbon dioxide and water. And that is what I call the caloric pathway, and it generates energy. So fructose can generate energy too, right? It's generating energy through this classic mechanism where foods are broken down. And glucose is broken down that way. And fats are broken down that way. And all foods are broken down that way. It's the caloric pathway. And everyone focuses on calories because they say, it's a calorie. But fructose, while it's doing this calorie pathway, generates this uric acid as a side chain reaction. It's not related to the calories. It comes off when the ATP gets consumed. There's a reaction that prevents the ATP from being remade. So ATP is broken to AMP, ADP and AMP. These are like phosphates come off the ATP. And then that AMP usually is, and ADP usually are turned back to make more ATP. But the reaction pulls off that AMP and removes it. So you can't make the ATP back. And it turns it into uric acid. So it's removing your ability to make the energy. But then the uric acid has that extra thing where it goes and it stimulates this enzyme called NADPH oxidase. I don't know if you wanted to know that. That enzyme goes into the mitochondria, causes oxidative stress, stuns the mitochondria. And the uric acid also blocks this AMP kinase that is used to help restore ATP. It's like a 5-step reaction. The whole thing's aimed at reducing the ATP. And then that's like a big alarm. Hey, I don't have enough energy, so I'm going to eat more. But it's set up so when the food comes in, it's preferentially storing it as fat rather than making ATP.
Okay, so we know fructose is a big problem here. But before we go any further, any other foods or components of foods as they go through the physiology once they enter the body that have a similar reaction? Or are we just worried about fructose?
Alcohol can do a lot of this. So it also consumes the ATP fast, and so it can do that. But it's really fructose. Fructose is like by far and away. There is another way too. We'll get there. But actually, let me just at this point. So when this originally came up, we saw this fructose was activating it. And then we did a really cool thing. We did studies to try to figure out what's the role of calories and what's the role of the non-calories, So we could knock out. We took animals and we knocked out different things. So we could knock out the caloric pathway from fructose. So they can't make calories from fructose, but they still would get fat. So it wasn't the calories from fructose. It's not the calories from sugar that make you fat. It's the activation of this pathway. That was pretty cool. So, and then we knocked out just that side chain reaction. We could prevent animals from getting fat. So we actually know it's that side chain reaction.
Where uric acid is made.
Yeah, yes, the uric acid. that is what does it. If the fructose doesn't make uric acid, fructose is just a calorie. It's just like glucose and so forth, and you're going to regulate your weight fine. And people who lack that enzyme, they don't get fat. They can eat sugar, they won't get fat. And I should mention that although fructose is in fruit, for us, it's not the fruit. It's the sugar. It's table sugar and high fructose corn syrup because they both contain fructose. And they're making together, it's about 1/6 of all the food we eat comes from those two sources. The table sugar or sucrose, which is a fructose and glucose bound together, and high fructose corn syrup, which is this other sweetener. So we're getting every 1 in 6 calories we get is usually from sugar for the average American, or high fructose corn syrup. So that's the source of fructose. And if you look, when sugar was introduced into the diet, we started eating more and more sugar and then high fructose corn syrup, and it correlates beautifully with the rise in obesity and diabetes and so forth. So, and now we're eating so much that even if it's going down a bit, we're kind of like over the limit. So we're just still eating too much. Okay, so getting back then, so fructose, acts by making us eat more. And drops our energy metabolism, shunting energy. So there's all kinds of mechanisms, but eating more is part of this switch. So eating more is part of the switch. So people have known that scientists have known over the last century that we are eating more. We are eating more. We're exercising less. And this has led to a group of scientists to say, hey, you know what? It's just you're eating too much. But it's actually activated by this biologic switch. Because when you block the switch, animals will not eat more. Okay, so it's that simple. So then the question is the metabolic syndrome or the obesity, this thing we're getting, is it from eating too much but driven by fructose? It's still driven by fructose, but we're eating too much. And so what we did was we did a thing called pair feeding, and that's where all the animals have to eat the same amount of food, and this way you control for that hunger. So if this group of animals, if one group of animals is hungry and the other is not, it doesn't matter. They're all going to eat the same amount. And so what you do is, the animal that eats the least, all the other animals have to eat that same amount. So if the control animals aren't so hungry, then those hungry animals are just going to stay hungry. Okay. And so when we did those experiments, we found that weight gain and, putting on the big amount of fat really is driven by eating more. So eating more is a really big factor. That's why caloric restriction, actually lowers, weight. I mean, we are eating too much in normal. But we're also dropping our energy metabolism, and we're doing all these other things. And so it turns out that when you control for eating more, the weight will still go up a little bit because you're burning less energy, a little bit less energy, but you're foraging too. So there's not much change in weight. There's just a tiny change. It's a little bit. But then they still get fatty liver. They still get fats in their blood. They still get high blood pressure. They still get insulin resistance. So that those features of the metabolic syndrome are not due to eating more. But weight gain is related to eating more in part. Okay, so that was the big insight that, that the switch, some of it is driven by eating, making you eat more, but a lot of it is not. If your insides are getting sick, even if you're not eating more. And in fact, you can go on a caloric diet restriction. We did this. If you create a caloric restriction, but it's high in fructose or sugar, the animals will still get fatty liver. They'll still become diabetic. So, and then I published on a series of people. who are below normal weight, but eating the wrong foods and developing fatty liver and so forth. So, in fact, we just published a paper called Lean Fatty Liver, lean, because fatty liver, sure, if you eat more, eat a lot of sugar, fructose, that's going to cause fatty liver. But you can get it even if you're lean, if you're eating the wrong food. So that was the second big thing was, this importance of weight gain. And one of the, or of eating more. And one of the big findings is that, if you want to gain weight and eat more, eating fat is actually a good way to get a lot of calories. So fat's like 9 calories per gram and carbs are 4 calories per gram. And so if fat in itself won't make you fat because you'll regulate your weight. But if you first activate the switch by giving an animal fructose, then you give them fat, and then they'll gain weight much more than they will if they're just on a carb diet. Because if they're just on a fruit diet, for example, it's really hard to gain weight because they need that fat. They're hungry probably all the time, but when they and they can get fat, of course, but if you give them high fat diet with fructose, it's like night and day difference. And in fact, we did one study where we gave fructose to animals, made them leptin resistant, then took the fructose away, put them on high fat diet, and they gained weight like mad. But if we didn't pre-treat them with fructose, they didn't gain weight. It was modest. It was very mild. So anyway, so the bottom line is, fat is important as kind of a way to accelerate obesity. And the big insight there is, if you're on a low carb diet, you can eat a high fat diet. A low carb diet pretty much is a high fat diet, and you won't gain weight. And now we kind of know because there's not that fructose. Fructose is a carb, so when you go on a low fructose diet, you're on a low carb diet, you're on a low fructose diet. So that's why low carb diet, high fat seems to work. But if you're on a Western diet where you're eating a lot of carbs and fat, now the combination are working against you.
For somebody who is caught up in this cycle of eating fructose, causing the leptin resistance, and say that's causing them to eat a lot of fat, bringing in a lot of dense calories, how long does it take when they come off the fructose for the body to reset, or does it reset?
Yeah, it does. And so here's what's really interesting. If you remember, this is all working through the mitochondria, right? So the fructose stuns the mitochondria. So one of the first things is if you're like a super athlete, your mitochondria are incredible. I have a friend who studies, who's a coach in the Tour de France. And I mean, these super athletes have mighty mitochondria. So when they eat sugar, it won't phase them. They aren't going to gain fat because first off, they're exercising this huge amount, but their mitochondria are so healthy that it's hard to knock them down. Even with a little bit of oxidative stress, there's so many. Once your mitochondria are really working, they also upregulate their antioxidant defense systems. So the oxidative stress is knocked out. If you're 20 years old and you've been skinny all your life, and you're very active and your mitochondria are really healthy, you drink a can of a soft drink, it's not going to you're going to think you're invincible because you're not going to gain weight. And there's a lot of young, healthy, really people with good mitochondria who are that way. But over time, the more sugar you drink, the more you're stunning that mitochondria, and the more you're likely to shift into this biologic switch where you're shunting energy to fat. And then let's say you are now 35 years old, and you know that for the first time you're really gaining weight a little bit easier than it seemed, and initially. When you first gain weight, it's really easy to lose it because you just cut out some food for a couple of days. Everything comes back and you feel like you're back to your regular self. And that's because the mitochondria are not so damaged and they can recover quickly. But, over time, it gets harder and harder to do it. And so what happens is the mitochondria kind of get weathered a little bit, and then the sugar is causing the switch to suppress that ATP for a longer period of time. I have found that for most people, and especially like in animals, that when you turn on this switch and you get them leptin resistant, for example, how long does it take for the leptin resistance to go away? About 2 weeks is, some maybe 5 days, some 7 days, but somewhere between 7 and 14 days, you can recover to a very significant extent. And one of the things that I discovered was, as I was going into how people diet, is that there's often this period of severe carb restriction in the first 2 weeks of a low carb diet. It was in the Atkins diet, for example. And I realized that that's like really important. It's like rebooting the system. It's like getting everything to kind of come down, because another thing that happens, Jesse, is the more sugar you eat, the more fructose you eat, the more you metabolize it, the more you absorb it. It's like the system upregulates. And so we did this study in young kids, and if you're overweight, you absorb sugar better than if you're lean, and you metabolize it faster too. In fact, there's this sort of cool thing. They like, if you're really overweight, you'll absorb more fructose, but the blood levels will be lower because the liver metabolizes more, so there's less that can get to the liver, even though you're eating more, you're absorbing more. So there's all these systems that are up. The system wants us to eat sugar, so the more sugar we eat, the more we can metabolize it, the more better we get at turning it, helping us become fat. And so, but 2 weeks allows all these systems to kind of come down. And so I thought Atkins was pretty brilliant on his empiric ability to just pick 2 weeks, because that seems like it's sort of like an ideal period. And I do recommend for everybody, as probably many of us are being exposed, you can't help but be exposed to sugar, that every now and then kind of go on a low carb cleanse for, maybe a week or 2 weeks, to just kind of let everything boot back to where it should be. I do think that's a smart move.
I want to highlight a couple things you brought up earlier. One being not to fear fruit in moderation. I think it's important we get into that a little bit more, because we know it does contain fructose.
Yes.
And you said the real issue is from two things: sucrose and high fructose corn syrup. So basically, the way I'm seeing it is, if we go upstream and get to the root of this problem for people that have been tuning in here, it's to ditch those two things that are going to be found through processed foods generally. And that's getting to the root of this whole issue.
Yes. Processed foods, as you have championed, are really like one of the main culprits, probably the main culprit, because they add sugar, they add high fructose corn syrup. But when high fructose corn syrup came out, they realized that it was liquid and they could mix it into foods very easily. And they could make it just subtly sweet. And like crackers and stuff, just subtly sweet that you can barely tell. But our taste buds like sweet. And it induces a little dopamine response in the brain. And so we start eating foods and we don't even realize. I went to a restaurant. It was an Asian restaurant with my wife years ago. And gosh, I thought the food was like the very best I'd had in a long time for Asian foods. And then my wife and I looked at each other and go, oh my God, we like it because there's just a subtle sweetness. They've added sugar or high fructose corn syrup. So processed foods and foods where sugar is added. But the problem is there's so many foods where that is a problem. But when you go to the grocery store, read the labels, see if you see high fructose corn syrup or sugar in there, and try not to pick that. It's so much better to eat natural, whole foods as opposed to these processed foods. It's just unbelievable. And then the other thing is fruit. So when you get a natural fruit, it's got so many good things. It's got fiber, vitamin C, potassium. It has flavonols, which are these natural substances in plants that are good for the mitochondria, good for your health. And they actually counter some of the effects of fructose. We have found, for example, that quercetin, which is in apples, can block uric acid, lower uric acid. Vitamin C actually blocks the oxidative stress that your fructose does to the mitochondria. The fiber slows the absorption of fructose, and it's really the concentration that drops that energy level. So if the fructose trickles in, it's more like a calorie, but when it goes in and it's strong enough to drop the ATP, then it's activated the switch. So the fiber, all these things say that natural fruits should be good. And plus, most natural fruits have 4 to 8 grams of fructose, which is nothing compared to the 25 grams, 30 grams of fructose in soft drinks. So because of that, natural fruits do have some fructose, but they have a lot of good things. And then my friend, Josh Rabinowitz at Princeton, did some beautiful studies that showed that when you eat small amounts of fructose, the first few grams are inactivated in the intestine. And so in the liver is where most of the action is. So you probably need just to remember that when you eat food, it gets absorbed in the intestines and then it goes to the liver. But if the intestines kind of sees the food first, and it can actually remove some of that fructose. And it's just like the amount in a natural fruit. So when you eat a fruit or two, you're getting all these good things, but the fructose is not causing the problem because you're only needing a small amount. And so all the data, epidemiologic data, scientific data, suggests that eating fruits is actually associated with better health than with less health. And we did a study. I did a study where I gave a low sugar, a low fructose diet to overweight women. I did this with Magdalena Madero in Mexico. And we had these overweight, actually it was men and women, and we gave them a low fructose diet with or without fruit supplements. So when the one with fruit supplements was not really truly a low fructose diet, it was a low sugar diet, really. And we found that both worked. So long, and actually people liked the diet where you could eat some natural fruits. Having said that, you can beat the system. If you make fruit juice where you get rid of a lot of the pulp and now you put 5 fruit into 1 glass and then you drink it really fast, you're going to activate the switch, okay? You're going to do it. If you take, fruits, certain fruits are higher in sugar, apples, pears, plums, watermelon, grapes. If you eat a large amount of them very rapidly, like that bowl of grapes or several bananas, you're gonna get it. It's gonna activate the switch. So dried fruit. Oh God, I love dried fruit. Jesse, do you like dried fruit?
I do, yes. And I wanted to get into this, the juice and the dried fruit. Also smoothies. Let's talk about these because they're often considered healthy. So we got to talk about what they're doing.
Some of them maybe, So one of the things is I've not personally studied smoothies, and it may well be that some of them where you actually have the pulp in there, maybe they're not quite as bad. Or likewise, things like carrot juice and things like that. We don't know enough about it to be certain, but we do know that if you take multiple fruit, let's say that an apple has 8 grams, you put 3 fruit together, you got 24 grams. And I did do a study with apple juice, and I found that if I gave apple juice to people and they drank it fast, it was like a soft drink, and they activated the switch. We also did it where they drank it very, very slowly over, like more than an hour. And then it was hard to see if the switch was activated. We didn't do liver biopsies, which would have really shown it, but we just looked at it from markers in the blood, but it was much less. But apple juice is sort of like soft drink, When I was a kid, we would have apple cider with cinnamon every Halloween. And, I loved it. Now, unfortunately, I kind of view it like a soft drink, and I don't recommend it. But we do need to do more studies. As a scientist, I try to remain as open as possible to all of this. So, but I do not recommend fruit juices. Fruit juices have been associated with obesity in children. The American Pediatric Society many years ago suggested to limit juice, and I have some evidence that juice, in particular, may be bad. That it may even increase the risk for food allergies. I would not. I would encourage you not to drink a lot of fruit juice. If you just love juice, get the small glass and sip it. Try not to guzzle it, and try to keep it down. So that's fruit.
So when it comes to the switch, we know a big player is fructose. We've gotten into the detail there. I want to make sure we give people a comprehensive analysis of this whole switch and different things that can activate it. Because if they've eliminated fructose or they're having it just through whole fruit and they've got that covered, we want to make sure there's no other angles that the switch is being flipped. So let's cover those.
Oh, gosh. Yeah, so the story got to be much bigger after this. So, around 2010 or so, I was really aware, 2008, that fructose was the main player driving obesity. But clearly, there's some people who are not eating a lot of sugar. They're really trying to avoid this, and they're still getting overweight. And so I knew that there was another mechanism. And I even wrote a book. My first book, called Sugar Fix, was really about fructose. And it was the first low fructose diet. And I did have some people really have incredible responses. But I also had some people who didn't. And one of them was Jimmy Moore, is this wonderful guy. I don't know if you're well aware of him, but he has a website and podcasts and all kinds of things. And he found that for him to lose weight, that he had to go on a low carb diet. It couldn't just be sugar. And I had to admire all these people going on low carb diets who were really losing weight. And so I sort of knew that bread and potatoes and French fries couldn't be good, right? And French fries are just starch. There's no fructose. They're fried, so there's fat and salt. And but it's considered the most fat-provoking of all foods by some studies. And so the question was what could happen. And the big breakthrough was with discussions with my co-investigator Miguel and Aspa, and he'd been studying how animals can produce fructose. And came from another laboratory where they were studying an enzyme reaction in which glucose can be converted to fructose. And it turns out that there's only one way the body can make fructose, and that's from glucose. And so we had this kind of insight that when you're eating potatoes, you're eating a lot of glucose because starch breaks down to glucose. So starchy foods like rice, potatoes, bread, when you eat them, the glucose in these foods, the starch in these foods gets converted to glucose. And then the glucose can go up in your blood, and people a lot of people have these continuous glucose monitors. Maybe some of you who are listening do. And these are little monitors that can measure your glucose moment to moment. And when you eat a, quote, high glycemic food like bread, the glucose from the starch in the bread's broken down to glucose, and the glucose goes up in the blood. Now, normally we keep our glucose levels at a very restricted level. We like to keep it at a kind of a low level. But when it goes up above normal, it gets active. This stimulates insulin and other things. But another thing that gets stimulated is the conversion of some of that glucose to fructose. And so when the glucose goes up in the blood, it can activate this process to make fructose. And the classic is a diabetic. A diabetic has high glucose all the time, and they're always making some fructose, more than other people. So, it was known that diabetics make fructose, but no one really thought about, eating a piece of bread and making fructose. And that was really the basis of our work. And so we went on and we did these studies, and we found that when we gave glucose to animals, that some of that glucose was being converted to fructose, and the fructose was activating the switch. And then this kind of led to a kind of an interesting thing, because in the literature, everyone was saying that the way low-carb diets were working was because you're restricting the glucose, so you're restricting the insulin, and the insulin was what's making us fat. And it turns out that it's a little more complicated than that. It isn't really it could still be the insulin's still playing a role, but it's because glucose gets converted to fructose. And then the fructose is driving fat, in part by causing insulin resistance. So the insulin levels go up very high in the blood and when you're insulin resistant, and that is playing a role in fat accumulation. So insulin is important. This carbohydrate insulin theory is important, but it's really working through fructose to make you fat. And if we take animals and we block their ability to make fructose, we can protect them almost completely from carbs. They still can get a little bit of fat from the insulin pathway, but basically carbs cause obesity largely through this ability to make fructose. So that was...
Well, let's get practical. This just opened up a whole new area that we gotta make sure we cover. So for somebody who is having healthy carbs, say sweet potatoes, root vegetables, in moderation, now they're worried about that getting converted over to fructose and flipping the switch. So let's rest their minds. Like, what is it?
Yeah.
How do they consume healthy carbs without causing a problem?
Yes. So it turns out that if you're eating healthy carbs, and there are a lot of healthy carbs. So first off, if they don't release glucose very fast, like most vegetables, they don't release. They don't have a lot of glucose that leads to a very high blood level. So one way that fructose is made is if the blood glucose levels go up, and so that's classically with the four big ones are cereal, potatoes, rice, and bread. But then there's another trick, and the other trick is that although the glucose levels can go up a little bit, how much fructose is made is probably largely driven by another factor, and that other factor is salt. So the way to think about it is glucose is what gets converted to fructose, but there's a reaction that drives that conversion. And that reaction is really driven a lot by dehydration and salt. And when you're dehydrated and or if you're eating salt, and both cause a similar change in your blood electrolytes or blood salt concentration. So if you're losing water, the salt in the blood goes up. And if you're eating salt, the salt in your blood goes up. And when the salt goes up in your blood, that triggers the conversion of glucose to fructose. So what I'm trying to say is, back in Ireland in the 1800s, people were eating potatoes almost every day, but they weren't getting fat. But they probably weren't eating the big starchy potatoes as much as we are today. We've gotten better at making them starchier and better tasting. But one big difference is that we're often adding salt, French fries with salt. We eat salt on popcorn and all these things. And the salt raises the salt concentration in our blood and activates the enzyme that converts the glucose to fructose. So salty French fries are much, much worse than a little bit of baked potato that has no salt added. Okay? So there are, but having said that, you don't want to be eating a lot of a potato and get that glucose level up high. So it's a combination of how much carbs and whether or not you're activating the chemical reaction. So the chemical reaction is activated by salt and dehydration. And now when you understand that, now you understand in the very beginning of our talk about heat stress and dehydration and climate change, because if we're not drinking enough water, we're getting slightly dehydrated. We're turning on this enzyme to make fructose. So now we got an enzyme turned on to make fructose. So the subtle way we get fat from climate change is probably because we're activating this stress pathway to convert glucose to fructose. And so once that's activated, then, we can convert more carbs to fructose easier.
That's great. Thank you for tying that back together. So far, just to highlight things that we need to consider: carbs, fructose, and then now we have salt and hydration kind of coupled together. Yeah. We got to make sure we have enough hydration. And then that you also have to factor in how much salt you're having with the hydration to make sure that salt is within balance with how hydrated you are. Do I have that right?
Yeah, you got it right. So like the first half is, sugar is the bad guy. And now we're learning that high glycemic carbs can be turned into fructose as well. And now I'm bringing up another whole pathway for making fructose, which is really carbs plus salt, and or carbs plus dehydration. And here's where an insight came back from nature. We're going to go back to nature because to understand why these things work, it turns out that nature holds the secrets. And so it turns out that when an animal hibernates, they're not drinking water either. So like when a bear is hibernating, not only is he sleeping and not eating, but he's sleeping and not drinking. So where do they get their water? And it turns out that when you burn fat, you actually produce water. So water is produced when you burn fat. So fat doesn't contain water, but when you burn fat, you produce water. So fat is another source for water. And that's why some animals in the desert carry fat in their tails, because they don't want to carry it in their body because it will insulate them and get them hotter. But they can use the fat in their tails to give them water at key times. And, animals like the camel has a hump on its back. And it turns out like there's a desert rat called the sand rat. And it's called the fat rat because it loves to get fat. And interestingly, when it's in the desert, there's so little food around it, it really doesn't get fat. But we believe it's activated this pathway like big time because it lives off salty water. And then when you take it out of the environment where there's like no food and you just give it a little bit of regular food, it becomes enormously fat and diabetic very rapidly. So it's the same story. So it turns out that fat is a source of water, and a lot of animals try to activate these pathways so that fat can be a source of water. And one of the easiest ways to do that is to eat salt, because that kind of creates a sense of dehydration. So it helps you activate the switch to help convert carbs to fat. And like deer and so forth will search out, salt licks. They're probably activating this pathway so that this not high quality carbs they're getting from grass and things and leaves can be converted to store energy. So salt it was historically meant to be a mechanism to eat so that you could also help store fat. So it's kind of like searching out for sugar, and we have sweet taste receptors to help us find sweet foods that might contain fructose, and we have salt taste so that we can find foods that we like that have salt, and they also tend to help us activate the switch to become fat. And this was all part of the way to survive. So it turns out that people who are overweight, it's not well known, but most people who are overweight are eating not just, more food or whatever, or carbs, but they're also tend to be eating a lot of salt. So obesity is associated with high salt intake, And it's also associated with not drinking enough water. And the studies have shown that people who are overweight or obese tend not to be as hydrated as well as lean people. And in fact, we could take animals, and if we hydrated them, we could turn off this reaction and over time reduce their weight and their risk for diabetes. We could even reverse some effects on insulin resistance. And so generally, I think drinking water is the secret to health, and staying well hydrated is important. And you want to drink to the point where your urine's just got a light yellow tinge. You don't want it to be perfectly clear because you can overdrink. And we don't want that to happen because you can intoxicate our water if you drink too much. So something like 8 glasses of water a day, it's probably like 6 to 8 is probably enough to, turn off this chemical reaction, and it will help you lose weight and do all these wonderful things. But don't drink huge amounts of water. Please don't do that.
Another category of food we got to get into that we have a taste for, that we're drawn to, is the umami foods.
Yes.
Talk about how that fits into this puzzle.
Yes. So there are 5 tastes, right? There's sour and bitter, which kind of encourage you to not eat those foods. And it was probably developed because some of these berries that are sour and bitter can contain toxins. Over time, I do like sour taste, but in general, most people, sour and bitter was really to say don't eat these foods. And sweet and salt are the two, to encourage foods, and both of them seem to have an activation of the switch. But there's a 5th taste, and the 5th taste is called umami. It was discovered in the early, maybe around 1900 by a Japanese scientist, and it's, why some seafoods that commonly eaten in Japan are viewed as quite savory and tasty. And sometimes it's called the savory taste. And, when you make gravies and you simmer it and it gets that rich kind of rich sauce, oftentimes that's high in umami. Blue cheese is high in umami, and beer, it's not just the alcohol, which has a little bit of umami, but it's really the brewer's yeast in it that makes the beer taste so good. Tomatoes, like dried tomatoes, have umami. So there's all these foods that we really view as healthy, that are umami foods. And when they try to figure out what is it that's in common with all these foods, they're high in glutamate. And some people use this thing called monosodium glutamate, or MSG, and they add it to foods. It's common in Chinese restaurants. And people like MSG. If small amounts of it tend to, taste good. A lot of it can cause, headaches and stuff, but small amounts are often added to foods. And then the other part of umami is a thing called AMP and IMP. And you may have heard me mention AMP earlier, because when ATP is broken down, it makes AMP and IMP, and that's on the pathway to make uric acid. And it's actually in that reaction that activates the switch. It's so scary. And it turns out that when you eat glutamate, part of it gets converted to uric acid. And people with gout have high glutamate levels. And it turns out that obesity, when they do a thing called metabolomics and they measure in the blood, what are the 2 highest things associated with obesity? Uric acid and glutamate. It's like right there. And so what we did is we did a study where we gave animals umami foods, and particularly we gave them glutamate or AMP and IMP, or the combination. And when we did that, they became fat. It activated the switch. We could even activate the switch by adding uric acid to the drinking water. It's so sad. And we realized that the umami flavor was really a way to seek out foods that could activate this part of the switch. So it's right after the fructose part. So fructose gets converted, and this can kind of engage it directly. Now so there's some good news. I do have good news for you, Jesse, and that is that umami is a very potent way to induce obesity, but we eat very little umami foods. I mean, the amount of umami we eat is so small compared to sugar, and so small compared to salt. It really is not a big driver. I think if you're a heavy beer drinker, yes, that's probably the main mechanism driving fat and fatty liver and high triglycerides in your blood and high blood pressure. You know, and I think that if you're eating a ton of shellfish, like if you're eating fried shrimp, probably if you're eating a lot of it, you're definitely giving yourself an umami load. And processed meats, when you process them, it releases the glutamate a little bit more. So processed red meats compared to regular red meats. So regular red meats do a little bit of it. White meats don't do much at all. Some I would say fish are more protected. Fish are good. I'm more paleo than many. And I'll tell you, the umami challenges the people who like paleo because, historically a lot of the umami is viewed as like meats, but it really is processed red meats more than red meats. And then red meats are more than poultry. Fish are dark fish like mackerel and anchovies are sort of high in umami, but most fish are not, and they have so many other things that are good like omega 3s and so if you do read my book, I go into all this, but I don't want to scare you about umami. There's if you can overdo it with umami, just like you can overdo it with fruit, but in general, I would view umami as a minor player, except for those people who are like heavy beer drinkers or, shrimpophiles.
Alcohol has come up a few times now, and
Yeah,
especially
alcohol
beer, and you talked about the brewer's yeast. Other than beer and the brewer's yeast, let's zoom back and talk about alcohol as a whole and how it fits in here.
Well, it's a pretty scary story. So alcohol also, it doesn't raise salt in the blood, but the alcohol itself acts when it gets in the blood. It sort of acts like, and it affects the same pathway. So this chemical reaction that can convert glucose to fructose is activated by alcohol. So alcohol doesn't make fructose itself. Fructose is not made from alcohol. But if you have a drink and you're eating a pretzel, it may help convert the pretzel to fructose. So alcohol activates the enzyme. It's sort of like salt. It's like an accelerator. Now, it turns out that, they're all slightly different. So hard liquor is probably the more potent for converting it. And wine doesn't seem to be as significant based on clinical studies. But, heavy alcohol, especially when it's mixed with with sugar and all that, probably can activate the switch. Beer can activate the switch. Wine activates the switch less. But a terrible thing is like, most of the foods that we like can activate the switch to some degree. So what you come back with is you end up saying, okay, I understand why the nature's kind of working against us here. But if we know that these foods are bad and it relates to how much and how fast we eat them, we can still design really healthy diets that are tasty and so forth. And, we can moderate, I'm not telling you never to eat sugar. I still eat sugar, but I just try to reduce it, how much my exposure is. I certainly don't drink soft drinks. I'll still have a birthday cake on my son's birthday, but, but I try to really watch it because I now know these are the foods, like these foods are really bad. These foods you have to be a little careful with. These foods are safe. And then there's some foods that are actually beneficial, things like coffee actually antagonizes the switch. I mean, it actually reduces the risk for uric acid, obesity, and diabetes. Certain teas are really good. There's, we talked about small amounts of fruits, nuts, dairy. I know there's a lot of people anti-dairy, but it looks like it's fairly safe. Maybe the milk proteins like casein may not be as good, but a lot of dairy seems to be good, and and eggs. There's a lot of foods that are just great, and in general, natural foods as opposed to processed foods, should really be recommended. But I do go through this all in the book, and we go through that kind of depressing reality that the things that we really like can activate the switch, but it doesn't mean that we can't figure it out.
When it comes to the switch, we've talked about a lot of the players. Any other players that we forgot to mention?
I think we've hit the main ones. We really hit the main guys, and I think the one thing that we should talk about though is, the stages of obesity, and I really want to write this, put this on paper more. But initially we regulate our weight. When we were all born, we're regulating our weight well, and depending on how much sugar in our genetics and whatever, some of us can regulate weight all our life and others can't. But that's the first step. Start off, we're good. And then we get exposure to some of the bad foods, and we're turning on the switch off and on. And if our mitochondria are healthy, we just, we can resist the effects pretty well. But eventually it starts to really activate the switch. We start putting on a little bit of fat. And we're still at a stage where we can freely just reduce those foods, and we can correct that obesity without any concern, any worry. But the more we do it, the more we upregulate the systems, then now we're becoming, the switch is driving our obesity. And this is the stage where if you follow the things in the book, you can really make a difference. You drink more water, drink coffee, take vitamin C, all these different things, reduce the foods that really activate the switch, and you probably can go your whole life doing great. And then, there's people who have activated the switch so long that they're now at the next level where their mitochondria are kind of beaten up, and now they're not able to make that ATP even when the switch is turned off. So now, if we take those people and we try to help them and try to keep from activating the switch, it's still an important thing to do. But now we have to do another thing, which is to help them recover their mitochondria. And what's cool is animals recover their mitochondria. It's possible to recover the mitochondria. And, there are many, many people who know this, and they have the things that they promote. And I know you're an athlete, I believe, and that you're running marathons and doing all kinds of great exercise. And exercise is a fantastic way to stimulate those mitochondria to help them grow and get stronger, and you can recover them. And, my friend Paul McLean, who's a great obesity researcher, has shown that, if you tie losing weight with exercise, and this is in the animals, so this is really cool, that the animals will keep their weight down for a much, much longer time. They won't rebound. And it's because I personally believe it's because he's recovered, that this treatment is helping the mitochondria. And there are a lot of other ways to recover the mitochondria. People are working on it all the time, and there's books out there that you should check out. David Perlmutter has a really nice book. Steve Gundry has a pretty cool one, where they're talking about some of these ways to help recover mitochondria. And it's really at that level. And I think that the future's good. And my belief is that obesity is not going to be a major problem. Type 2 diabetes, they're going to go away. Because once you kind of know how this whole thing works, we can find ways to block it, not just by diet, but by nutraceuticals, by pharmaceuticals, and we can find ways to stimulate those mitochondria. And I believe that, this next century, we're going to be battling more of the effects of climate change and heat stress and toxins, but that this issue where we kind of ignored our nature and our biology, we're 90% there. I think we're going to cure obesity and diabetes, really in the next few decades. It's going to be dramatic. We're already have these GLP-1 agonists that have just come out, and guess what? It looks to me like they're working on this biologic switch we have because they're suppressing glucagon, which turns out, and we didn't get to this, but turns out that our switch ends at this hormone, and so I actually think that I feel good about it, Jesse.
I'm happy to hear that. It's a good way to round things up at the end here. But now that you brought up glucagon in the end, can you talk a little bit more about that?
Yeah, well, I can. So it turns out that, remember I told you that most people that are overweight are dehydrated. And I told you that a lot of people turn on this or eat salt as a way to activate the switch to make fructose. And as we studied this, we found a very complex relationship because there's a hormone in our blood that goes up when we're dehydrated. And that hormone is vasopressin. That hormone helps us hold on to water. And it turns out that it works through it's like classic nephrology or classic kidney disease biology is that when we get dehydrated, we concentrate our urine. Our urine volume goes down. The urine becomes concentrated because we're trying to hold on to water. And the reason is because a hormone gets released when we're dehydrated. Well, it turns out that obesity is associated with high blood levels of vasopressin. Everyone who's overweight or obese, probably the majority have a high vasopressin level in their blood. Not only do they have a high blood level, but people who have a high blood level who are lean are very likely to become overweight. So the vasopressin has been recognized recently as a beautiful marker for people who are at risk for developing obesity. The big breakthrough for us was when we realized that, vasopressin is trying to hold on to water. So vasopressin turns out to have also a role in making fat because that's another way to hold on to water, because when fat is burned, it produces water. And we discovered that vasopressin works through a receptor that no one knew about, really, that no one knew what the function was. And that receptor is called the V1B receptor. And when vasopressin works on that, that's even how sugar causes obesity. And that's even how dehydration can cause obesity. It's through this pathway that involves fructose and uric acid, but it's the hormone that drives that whole process together. So there's a nutrient that drives obesity, fructose. There's a biochemical metabolite in our blood that's uric acid, and there's a hormone that drives obesity, and that's vasopressin. And when it works through the V1B, it turns out that it stimulates glucagon as well as some other things. It stimulates the fructose pathway, but glucagon is a big, big player. And when they found that these GLP-1 agonists are curing obesity, they still haven't figured it out totally, but I've noted that GLP-1 agonists really suppress glucagon. And I go, aha, that's likely the mechanism because it's working. It actually would be working on this pathway to block it. So I believe that the GLP-1 agonists actually play a role in this obesity pathway, and it explains why it suddenly reduces your food intake and all these things, that it may actually be one mechanism for blocking the switch.
Interesting.
Yeah.
And Rick, before we part ways, one more thing I want to highlight, something you were talking about a couple of minutes ago. I think it's really important. The fact that when it comes to the switch, there's this continuum, depending on how long you've been chronically flipping that switch. And what happens there is that oxidative damage to the mitochondria. So basically, there's people that are early in the game that can make some of the switches we talked about earlier. But then for people that have maybe they're in their 50s and 60s and have been doing this for a lifetime, flipping that switch chronically, they might have to go a little bit more intensive, but there is hope for them. But there's things like exercise that they can do to rebuild the mitochondria. And this is what I want to end on right here. You gave the example of exercise, but can you give us a couple more things for people that are in that later category who really need to heal their mitochondria? What's some other things they can take on?
Yeah, well, so I would say vitamin C, coffee, dark chocolate, some of these things are all good for stimulating mitochondria. But also, I do think we should talk about exercise, because it turns out that it's really primarily one type of exercise. It's like walking fast or jogging or biking. It's kind of like where you're doing it for like 40 minutes at a level where you are, you're able to talk, but you're not, but it's a little difficult to talk. That seems to be the right level where you're not building up lactic acid and where the mitochondria are actually, being stimulated to work hard, and as part of that, they start to grow. So we call it's sort of called zone 2 exercise, but basically what it is it's a level where the mitochondria are working pretty hard, but at a level that is before you start building up lactic acid and basically closing down the system. So you don't have to exercise at high levels of intensity. You don't have to do weight exercise. I recommend all those exercises, but for stimulating the mitochondria, the main thing is get out 3 times a week, go 40 minutes, walk as fast as you can. If be careful if you're real old, or if you have trouble with your balance. But basically, you want to walk enough that you're a little short of breath, but you're still able to talk, or jog, or do the treadmill or bike. I actually like to bike. I find that that's very relaxing. I go into a park, I bike 3 times a week, and I bike hard enough that I can feel it, but not so much that I'm exhausted.
Perfect. Well, I'm glad you highlighted too the coffee, the vitamin C. I had thought those were more like in the mid-range, but it makes sense they would be applied to people that are further down the continuum as well. And with the exercise piece, I'm going to end on this. You talk about in the book, another layer to add to that would be to do it fasted. And this wasn't something we got a chance really to dig into, but intermittent fasting is another piece of this equation that you bring up in the book. And maybe we can have a part 2 down the line. And, there's a lot more we could get into here. So
yeah, actually, absolutely. Intermittent fasting and low carb diets also stimulate mitochondrial growth. And those are both wonderful techniques. I also, in my book, I talk about other types of diets, including one that I personally like, that where I've kind of taken what I've learned. But these are great examples, and paleo diet's a good diet too. So anyway, so good.
Rick, really enjoyed this book, really enjoyed the conversation as well. I thank you for your time coming on the show. We're going to link up the book. We're going to link up your social media, website, everything. Thank you so much.
Thank you, Jess.
Wait, don't go anywhere just yet. Stick around and watch my conversation right here with Dr. David Perlmutter. You'll learn even more about uric acid and how it might be destroying your health.
And even going from 1970 to 1990, in America, adults consume now 1,000% more fructose.